bilinear also in two directions, x and y. Okay, so this is our 4-node rectangular element. It is having 4 nodes. Okay, and each node having 2 degrees of freedom, x by x by x by x by. So this is our one of the element E, and this is node 1, node 2, node 3, node 4. Node 1 having coordinate x1 by 1. This is having x2 by 3, x3. Similarly, all nodes having coordinate. Now we have to find the shape function. See, we are having 4 nodes, so we will have definitely 4 shape function. We cannot have 3 or 5. Number of shape function equal to number of nodes. Okay, so we will have 4 shape function n1, n2, n3, n4. Okay, how we can find that shape function n1, n2, n3? See, at node 1, we are seeing this is connected with node 2. Also, it is connected with node 4. So this node 1 will have X effect, also Y effect, because it will have both effect. Because it will not move in it will move in this direction like this, in like resultant of this direction. Okay, so like how we can find that shape function for this bilinear element. So first I will tell you how to find shape function for in one direction. So for example, I will add one page here. Okay, so like this is our I will say write in other. This is our one of the element. So element length LE, x1, x2. This is length LE, and this is the node 1. This is node 2. So we are having 2 nodes, and it is having 2 x1, x2. So it is having 2 nodes. So, and it is moving in x direction only. This is totally horizontal. It is moving in one direction only. So you heard, I think you heard name this one like Lagrangian somewhere. So how to, by using Lagrangian method, how to find shape function? I think you know how to find, like I want to write n1. So n1 equal to x minus x2 equal to x2 minus x1. Yes. Similarly, what will be n2? N2 will be x minus x1, then x x1 or x1 minus x2. For example, I am saying this is truss. This is truss. It is having length L. This is x1 equal to 0, node 1, x2 equal to x2 equal to or L. This is moving in one direction because this is truss, so moving in one direction. So I think you remember what will be shape function. So we know that n1 equal to that what we can write x by L minus 1, then n2 will be I think x by L, yeah, like this. So these are, I think, by these equation you can get by different means. So what I'm trying to say, so by using that Lagrangian method, what we can get, if I will put value here, so for example I'm saying x1 equal to 0, so n1 equal to g, that x minus L by, this is length, this will become length L. So n1 will become x by L minus 1, and what will be n2? So I'm going to put value of x1 and x2. So n2 will be x minus 0 by L, then n2 will be x by L. I think this one you remember, these shape function. So by using that Lagrangian method, we can find that shape function n1 and n2 easily. Yes. Now I'm saying that this is only in one direction. For example, we are having 2D element. This is 2D element, and so this is node 1, node 2, node 3, and node 4. So this is moving in two directions. So like this will have x and y, x and y, x and y, x and y. So for example, I am going to find that shape function for n1. So I will write, so n1, it will have effect of x and y. So n1 x comma y equal to, then n1 in x direction, and then n1 in y direction. So see how we will write here n1. So like how we will write here. So this is having length L. This is having length this is having like coordinate x1, x2. So how I write n1 equal to x minus x2 by x2 minus x1. So for example, if I will write here similar by using similar concept, what will be our n1 here? So this n1 will be, we are talking about this horizontal direction. It will be, so I will say this is x1 and y1. This is x2 and y2. Similarly, this is x3. These are coordinate x3 and y3 and x4 and. So can you give me an answer? Are you getting something what I'm trying to say? Anybody?
Yes, sir.
Okay. So like then what is n1? N1 means like x minus x2 by x2 minus x1. This will be our n1. What will be n1 in y direction? This will be, so we are talking about on this direction, it will be y minus y4 divided by y4 minus y1. So like this we can write for this this element. This will be our n1 x comma y. Similarly, what I am trying to say here, see, so like for this this is x1 minus x1. This I missed that one. I wrote another way, but anyway it will become positive. So like for this shape, this node, for this node n1, so what will be shape function? So small n, so like shape function in x direction into shape function in y direction. We are not calling into, just to be like I'm saying here. So like n1 in x, n1 in y. So what is n1 in x? So x minus x2, then x1 minus x2. This is the length of this element. Similarly in y direction, y minus y4. Y minus y4, because this is our y4 coordinate. Then again this is length of y1 minus y4. So this will be our n1. Then what about n3? I want to write for this. So then n3, so this will be our x, this will be our y. So x minus x4, so this is our x, this is our n in x direction. So x minus x4, then this is a length, so x3 minus x4, and this is again y direction, y minus y2, then y3 minus y2. Similarly, y2, y3, and y4. We can get all these shape function. Yes, we can get easily, not an issue. One question, like this is one small problem, like we are having one 4 node element. So node 1 having origin 0 0, node 2 3 comma 0, node 3 3 comma 2, node 4 0 comma 2. We have to find n1, n2, n4. So what will be n4? N4 we know n4 will be, what will be n4? Like n4 equal to where n4? This is our n4. So see, this is in x, this is in y. So first I will write x. So x minus x3, then x3 minus x4. This will be our x. Then what will be y? Y will be, this is our y. So y minus y1, then y4 minus y1. But after putting value, you will get this. N4. Similarly, you can find N1, N2, N3, whatever you want, you can find by simply putting that expression. This is not big task, just we have to do only. Similarly, like for example, we are having 6 nodes, 1, 2, 3, 4, 5, 6. This is for 6 node rectangular element. Then I want to find N1. So this will be our N1 x small n1, then N2. Sorry. So for this, we will have 2 node effect, like this element and like I will say this element effect, this element effect. So this will be for, the total will be in x direction, but here we are having only one element, so this will be for one element. This is not a big task. So I think for today that will be enough. We don't or we have time. Still we have little time. Any doubt till now?
Okay, you can continue, sir.
We can continue now?
Yes, yes.
So what we can do? This is solution. Now we will solve some one problem here. This problem we were going to solve. First we will write this. First we will read this problem. Suppose 2D isotropic element, elastic body as shown in figure 1. So we have figure 1. Okay, this is our figure 1. In figure 1, we are having two triangular elements. This is element 1 and this is element 2. Okay, fine. They given that we are having total 1, 2, 3, 4, total 4 node, and they provided that for node 1 we are having 0, 0 coordinate, node 2, node 3, node 4. Node 1 having u1, u2, u3, u4, u5. These are displacement x and y. Okay, some information given, but now we know that we are having 2 triangular element. Fine. Okay, the temperature of, okay, suddenly the temperature of the body reach 150 degrees Celsius. Okay, so you are from mechanical or civil background, like both of you?
Mechanical.
Okay, and Nadlan, you are also from mechanical?
Yes, sir. Yes, sir.
Okay, then fine. So like you know that all this is thermodynamics, like not heat and mass transfer. Suddenly the temperature of the body reach, okay, this much. The coefficient, okay, this much giving, okay, this much, all the their parameter, okay. Now the body is discretized by with 2 CST element, okay, in figure. For a what is CST? CST means constant strain triangle. Triangle. So this is CST element. So like we are calling short form CST. Element shown in figure, okay, fine. For a CST element, psi1, psi2, psi3 are shape function. We are calling N1 here, N1, N2, N3. These are some different terminology, so no need to worry about. Okay, because we are having 3 nodes for one element, that will be 3 shape functions. So these are the shape function. And given that, see, in this problem, they given that this N1 or psi1 will be this much. Oh, this is they given that in general form. We have to, like, for example, I'm going to find that psi1. What will be psi1 from here? From here, what will be psi1? Or I will say equal to N1. What will be our N1? N1 will be 1 by 2e. 2e means total area of that element. Then what is alpha? Alpha we are calling like A1 in our terminology. And what is beta? Beta we are calling B1. X, what is gamma? We are calling C1 by. Okay, then how to find B, A1, beta, like how to find alpha, beta 1, gamma 1? This is our, they given that. So what will be A1? Like A1 will be, I will write here, A1 will be, A1 equal to, according to A1, like equal A1, so it will be X3 by 2, then by 3 X2. Then what will be B1? B1 equal to simply, and then B2 minus B3, what will be C1? C2 equal to, C1 equal to that C2, then C X2 minus X3. So this will be our value. That, okay. They also mentioned that I, J, K are the permutation of natural order. Okay. They mentioned that A is the area of CST element, that element total area. Okay. Now we have to find that answer of linked 2 to 6 question, and coordinates are given in mm. I think question is clear for you, right? Yes, this is clear. Now in FEM, I also told you, element stiffness matrix will be like this. This is given that. Okay. Consider order of node numbering 1 to 4, like 1 to 4. So like 1 to 4. Okay, so like if I will like they are saying consider in anti-clockwise direction. So in this way it will be 2, 3, 4, like this. 2, 3, 4. It will be 1, 2, 4. That is okay. What we have to find? What is the strain element of this? What is the strain displacement? This matrix we have to find for element 1. For this element, we have to find that this matrix. Where this is here. For this element, we have to find where yeah. This matrix we have to find for element 1. Okay. Anyone want to try, or should I start solving? Hello.
Yes, sir.
You want to try this problem?
Sir, I have another doubt in assignment number 8. Can you solve that?
Assignment 8.
Yes.
Okay. Okay, so let me open assignment. I didn't see an assignment. Okay, let me open where is assignment 8. If I know, I will try to solve. If not, then again next class I will solve. Okay. So just
Okay.
I'm not that much expert. Okay, we assignment 8. Assignment 8. So like you are saying that our class assignment, or you are saying that your assignment?
Sir, yeah, NPTEL assignment. Class
Okay,
assignment.
then so give me, tell me that question. Or you want to share your screen?
Question number 6, sir.
I don't have that assignment. Can you show your there? Can you share your screen?
Okay, sir. Please wait for 2 minutes. Sir, my screen visible? Hello?
Yes,
Hello.
it is extremely visible.
Okay, okay, sir. This one, sir. Sir, have you got it?
Can you hear me, Because?
Yes, sir. Sir, have you got it?
क्या क्या हो गया? Can you hear me now, Because?
Yes, sir. I can hear you.
Oh, I got disconnected from so yes. So what the? Can you tell me what the issue?
Sir, I I couldn't solve this question.
See, what the boundary? Can you tell me what the boundary condition?
Okay, okay, sir. I'm scrolling. Sir, this one the questions. This is a linked question.
So consider two-dimensional elements subject to reflex via position. Okay, this much boundary condition of domain shown in the figure. The domain satisfies two number single element and degree of freedom so as shown in. Solve domain finding note 2, note the answer given.
So question number 5 is okay, but question number.
Okay, then go. Okay. One, let me take one screenshot for this one.
Okay.
Yes, now go down.
Okay, sure.
See, this is okay. You got this answer.
Yeah. The question number 5 is okay, but question number 6.
So, like only issue, like you are not understanding how to put that boundary condition. That's it, na?
Yes, sir. From the lectures which I have learned, I try to do this, but my answer is different than the options that are given in this
Okay,
question.
one thing you know all these stiffness coefficient KU, KQ, you got the all the.
Yeah, sir.
And TU, TK you also got, right?
Yeah,
T2, T3.
yeah.
This is T2, T3.
Yes, sir.
Now, like, let me know what is F and see. Only issue what is F and Q. This is the main issue, right?
Yes, sir.
So 1 minute.
Actually, when I am solving this question, I got the matrix like. Sir.
So this is our flux per unit area, and this is flux per unit length. So this is our internal force, this is our external. So because are you able to hear me?
Sir.
So see, like, can you go up that main problem?
Okay, sir.
See, like, what is Q? Qn is the, like, if I will say like in force or in like heat and mass transfer terminology, this is flux, like, or heat per unit length, right? This is Qn, correct?
Yes, sir.
Qn, flux per unit length. And what is F? Like, I will try to explain another way. Like, we are having this one body, and this is generating heat, or like this is having.
Sir, your screen is not visible. Please share your screen so that I can.
Okay, I will just speak. Can you hear? You cannot see my face also. Okay, but just see, like, we are having internal force or external force, right?
Yes,
So
sir.
every time when we are talking about internal force, like we are talking about per unit volume or per unit area, internal force.
Yes, sir.
And external force, no, mostly we are talking about per unit length. So like this
Yes, sir.
small Qn is the like flux or heat per unit length. So we will call it as a external force. And this F, which is the internal force, like strain or strain. So we are calling per unit area. So when
Yes,
you
sir.
are putting that value, you have to multiply by length or area, correct?
Yes,
You
sir.
are doing that one.
Actually, I'm solving the question in the same manner as it was solved in the lecture by the professor.
Huh.
But
One
after
minute.
solving this question,
1 minute, 1 minute. I will give you correct way. Um, Elemental force. One more thing that because are you
yes, sir.
transferring that load to node, or you are just are you transferring node load body, like full body to node at each node
Yes, sir.
by using shape function? Did you
Sir,
get
I
what
just solve it like the professor was solving.
Can you
I
show
have
me that professor, that derivation? By the way,
uh,
you have PDF or some notes?
so yeah, I have solved on it in my paper. And
Okay, 1 minute.
what I did, I calculated the stiffness matrix at node one element for element one and for element two, and then I merged one and two. After that, when I
See, let
calculated,
me share my screen, okay?
okay,
1 minute. Then you will get some idea. I think you are doing correct. Only one thing I observe, that I think you are some missing that is shape function somewhere. Can you stop your screen?
okay, okay, sir.
Yes, see. I think now from there you will get idea. So from here you will solve. Like we are having one body. So this is like 3D body. I will say this is 3D body. So like we are having, see, this is, I will say this is body force per unit volume. Okay, this is our body force, or I will say external force, or this is our internal. This is external force per unit area. So if I want to transfer to any node, what we have to do, we have to multiply by this shape function, force into volume. Similarly, plus shape function, both into volume. So according to your problem, where is your screenshot? I forgot. So like according to your problem, I like they are having this much, like this. So you are having some like F and Q. So this is like a force, like flux per unit length for element 1 and element 2. We are having two elements, right?
Yes, sir.
Okay. So like I will say this is node 1, node 2, node 3 and node 4. Just see here. So I think next you will get idea. So node 1, node 2, node 3, node 4. First, what you did, you calculated element stiffness for node 1, element stiffness for node 2. You got this
Yes.
one, right?
Yes, sir. Yes, sir.
Then you added, you got one global matrix, one K1 plus K2, you got one matrix.
Yes, sir.
Correct. Similarly, see, on this surface, they are putting this flux per unit length. So I will say this is like this force, because we are talking about only 2D. So this will be like for here, for this side or for this element, what will be like, this will be N transpose into Q into our like length. This I will say this is like flux 1 plus this one also. What we have to do, so like N transpose F into area of triangle for this triangle area 1. So this will be for this one Q1. Similarly for this element Q2, but we don't have anything here. Here also we don't have anything. So this will be only for N transpose F into A2. Did you get something what I'm trying to say?
Yes, sir.
So you are doing also same thing.
No, sir, I am not doing this thing.
So did you use that same function? Look, actually, why we are doing that? Why we are multiplying for same function? Because this is a distributed. I will talk about load, because this is distributed load, and we have to transform, or like I will say, this is distributed heat, and we have to transfer to each node.
Yes, sir.
By using shape function.
Shape function.
Similarly, this way also. Let's try to do this way. Or next class.
Okay, sir. I will try it this way.
Or next class, show me your notes, some like what you written. Then I will be more. It will be easy for more to understand.
Okay, sir.
Okay, now.
Okay. Thank you, sir.
So, any other question? Any other question? Because
No, sir.
then what we can bind up for today. This is enough for today, I think. Oh, this problem